Hi, welcome to Naukri Learning. This is Kanika Garg presenting machine learning techniques for sentiment classification. I have done PhD in artificial intelligence and machine learning and has total of 8 years of experience in machine learning, deep learning, natural language processing, etc. I am passionate about learning more about it, and I enjoy researching and experimenting with different artificial intelligence techniques and applications. These are the topics we are going to cover in this session. First, we will talk about sentiment classification. Then what are the traditional methods that we used to use for achieving or for doing this classification. Then we'll learn about some deep learning methods. Then, of course, the most recent ones are the pre-trained models for sentiment classification. And finally, we will have some course recommendations. Now, let us first understand what sentiment classification or analysis is. First of all, this is a natural language processing task. That means here we are going to process the natural language, that is the language the humans speaks and understands. The language right now I am speaking is a natural language. So first we must understand that language and then process it for our usage. So this is one of the most important NLP tasks. It is also known as opinion mining, or sometimes it is called as emotional artificial intelligence or emotion AI. It is basically an algorithm used to determine the opinion of the masses about a specific topic, or maybe an object, or maybe some product. So with the growth of social media, blogs, discussion forums, and various review sites, major companies came to realize that being sentiment aware or emotionally aware can help them gain the insights of what exactly user is thinking, or the user behaviors, and how to track and manage their online presence and image, and how to boost their own product. So it is basically about gaining the loyalties from the consumers and making their brand more emotionally available to the masses. For example, there are so many companies like Coca-Cola and Cadbury's, or maybe Hindustan Unilever, they generally plays with the sentiments and emotions of the masses. So basically, a sentiment analysis is understanding the sentiment, or say intention or intuition behind the text that has been written and that has been available on the internet or maybe any other review site. So majorly, when we initially used to perform sentiment analysis, it is basically categorized in three categories. The one is the positive, then negative, and the neutral. Positive, of course, means when we have some positive feedback towards someone. For example, if I say, I really like this product, this is a positive feedback. Now, if I say, I really don't like the handling of this product, it is very difficult. So it's kind of a negative review from my side. And if I say, okay, it's okay, it's neither too good nor neither too good nor too bad, so it's more like the neutral sentiment for us. But as the technologies advanced, the sentiment analysis has dug deeper into the emotional AI, where the text has been analyzed on based upon their emotional content. For example, reading the content, I can say whether this is a happy content, this is the angry, and maybe more rational ones. So sentiment analysis has come this far now. So let us study how we can perform sentiment analysis using various methods. So these are the three kind of methods we are going to learn today in our session. First one is the traditional method. Then we are going to study about the deep learning methods, which are introduced in some years back, and then the pre-trained models, which are very in right now. So in traditional methods, we are going to learn about naive Bayes, SVM, and linear regression. Then we are going to learn about the deep learning methods like LSTM and CNN. And then we are finally will be learning more about the pre-trained models such as BERT. So moving forward, and let's talk about the traditional methods. Why these are called as the traditional methods? Because these are the initial machine learning algorithms that we were using for sentiment analysis. For example, naive Bayes. Naive Bayes was considered one of the most effective algorithm when we have data in hand is very few. So the naive Bayes algorithm is basically a supervised machine learning algorithm. That means uh, we have the input as well as the available output for them. Okay, so this algorithm takes the name from the Bayes theorem, and it is based on the probability. So it's a probabilistic algorithm. So it is a probabilistic classifier that is often used in natural language processing tasks like sentiment analysis, word sense disambiguation, etc. So here the Bayes theorem is used to determine the probability of a hypothesis when prior knowledge is available. So it's basically depends on the conditional probabilities. So what exactly naive Bayes does to calculate the sentiment analysis or to perform sentiment classification is it calculates the polarity of a word against each other word available in a sentence or a document. So with machine learning model trained on the word polarity, it can calculate the likelihood whether that word or maybe the phrase or a sentence that we are working on is positive or negative. That means it can just predict the likelihood whether it is the positive or a negative word or a sentence that whatever we are working on. Then let's talk about SVM, which is support vector machine learning algorithm, and it is another the very famous algorithm, and generally these are the algorithms that usually perform state of the art operations. So it is another supervised machine learning model. It is similar to linear regression that we are going to learn, but it is more advanced. What happens is SVM uses algorithms to train and classify text within our sentiment polarity model, taking it a step beyond, say, XY prediction. Okay. That means for a simple visual explanation, let's suppose we have two tags, red and blue, with data features X and Y. We'll train our classifier to output XY coordinate as either red or blue. So the SVM then assigns a hyperplane that best separates the tags. In 2 dimensions, this is simply a line, as you can see in the figure here. Anything on one side of the line is red and anything on the other side is blue. So for sentiment analysis, this would be like positive and negative. So in order to maximize machine learning, the best hyperplane is the one with the largest distance between each tag. As you can see here in the diagram, we have drawn two lines. So the one which is best is that is drawn solid because the distance between the points, the data points at the hyperplane is maximum in that one. So in SVM, we have to choose hyperplane in the sense that the distance between each tag or the data point is largest between them. Now, let's talk about linear regression. So linear regression is a statistical algorithm which is used to predict a Y value given X features. So basically linear regression follows an equation of a straight line. Again, we try to draw a straight line that can cover maximum of the data points. So using machine learning, the data points are examined to show a relationship. The relationships are then placed along XY axis with a straight line running through them to predict further relationships. So linear regression basically calculates the input that can relate to the output. So it will determine whether the words that can fall between positive or negative or anywhere between them. So it basically gives a continuous value. Suppose it gives a value between 0 and 1. So the values where it falls near 0, these are really negative, and that values which falls near 1 are really positive. And any values between 0 and 1, we can scale them up like from really negative to neutral, then to positive and to really positive. So this is how we can use linear regression. We can also use logistic regression, which is a classification algorithm and works on the similar principle. Now, let's talk about deep learning techniques. So one thing is there that deep learning techniques are called as deep because they use neural networks with various or many hidden layers. That means the data which is processed, which has to be processed, goes through various hidden layers, and it uncovers various truths about the data, and finally we will get the result. That is why it is called as the deep learning. So we have two major algorithms for deep learning. One is convolutional neural network and another one is RNN, and its advanced form as LSTM, long short-term memory. So let's talk about CNN. We know that CNN is majorly famous for image processing, but the way it works for image processing can also be worked on the word basis. So here the model performs convolutions in the embedded feature space of the words in a sentence. Rather than the pixels of the image, it works on the words in a sentence. So we say that convolutions occurs on the adjacent words, like it used to work on the adjacent pixels. So the model can pick up on the negations and or say the trigrams, bigrams, or the n-grams together. Like it, when we talk about the convolutions, so what we say is it generally picks up some of the pixels together and it works on it, and then slowly it moves forwards. Similarly, when we talk about the words in a sentence, it will work on some words together and then it will move forward. So it will help us understand some kind of dependencies it has on the various words. So it will help us with the sentiment classification along with some dependencies within a sentence. Now moving on to LSTM or RNN, recurrent neural networks. So recurrent neural networks, they are already very famous for natural language processing because it gives us a time series data. And for time series data, we generally know that RNN performs better than CNN. And what exactly LSTM works here is LSTM is a long short-term memory model, which is helpful in solving these kind of problems. So these are a special kind of RNN model that has the capability of learning long-term dependencies. So they are made to remember long-term data. So that makes LSTM model special in addition of a memory cell, which is an extra, say, a recurrent state, and each cell has multiple gates that control the flow of the information in and out of the memory cell. So LSTM is a type of course, RNN network that can grasp long-term dependencies. They are widely used today for a variety of different tasks of natural language. For example, text classification, speech recognition, sentiment analysis. So what exactly happens here is it's kind of a neural network, a supervised deep learning algorithm where neurons are connected to themselves through time. That is why I always said that it is a time series prediction. So the idea behind RNN is to remember what information was there in the previous neuron so that these neurons could pass information to themselves in the future for further analysis. It means that the information from a specific time instance is used as an input for the next time instance. So this is how LSTM or RNN works, and that is why they are helpful for sentiment analysis. The major drawback here being is every time we need to train deep learning model, either CNN or RNN, we need a huge data. And suppose we need to run our model, or we need to create our model where we have a little less data available, input data available. In that case, these are difficult to learn, or they may have some smaller problems in learning. So because of these issues, or because of some of the say insufficient data is available in for many languages. For example, if I talk about sentiment analysis of Hindi text, we do not have much of the data available for Hindi text even now, but we have a huge data available for English. So if we want to train our data for say English, it is also it's easy. But if I want to train the same model for Hindi, and if we do not have sufficient data, it is difficult to train the data. So in that case, we would like to have some models which are already trained, so that we can just feed our small data over it and just have an insight whether it can perform, or it can give us the ideas about what we want to know. So moving further, these answers have been given by the pre-trained models, and the major pre-trained models we are going to discuss today are Word2Vec, Glove, and BERT. BERT right now is one of the most famous model, but the pre-trained models were started with Word2Vec and Glove. These both models, they learn what the geometrical encodings, or say vectors of the words, from their co-occurrence information. So Word2Vec and Glove is basically converting the word to the vectors. And if I talk about the difference between the Word2Vec and the Glove, the Word2Vec works on the local data, whereas Glove will talk about the global word encodings. So they differ in that Word2Vec is a predictive model, whereas Glove is a count-based model. So Word2Vec learns their vectors in order to improve their predictive ability of loss. That is the loss of predicting the target words from the context words given the vector representations. In Word2Vec, this is cast as a feed-forward neural network and optimized as using SGD. And count-based models learn their vectors by essentially doing dimensionality reduction on the co-occurrence counts matrix. So they first construct a large matrix of word and context co-occurrence information. And then for each word, they count how frequently we see that word in same context. So the number of contexts is, of course, large, since it is essentially combinatorial in size. So then they factorize this matrix to yield a lower dimension matrix, where each row now yields a vector representation of each word. So these two, they work on the vector forms. Now, these are the pre-trained models. That means if I have a small amount of data and I want to see the results on my data, so I have these two models available with me. What I can do is I can just use them as it is and can feed my data to find out the output. But the better results have been given by the another model called as BERT, and it is generally giving the state-of-the-art results with almost all the languages available. What exactly BERT is? BERT is a bidirectional encoder representation for transformers. It is a new method of pre-training language representations, and it is vastly developed by Google, and it is released in later 2018. That means it is very latest and very new. So it is both contextual and bidirectional language model. That means it can learn from right to left and can also learn from left to right. Okay. So again, it's a open source NLP pre-training model. That means you can use it anytime you want, and it is considered the most groundbreaking development in the field of NLP, and is often compared to even the ImageNet movement in the computer vision. As we know that ImageNet performs the state-of-the-art results for computer vision. So it has been compared with that. So let's talk more about BERT. Now, Unlike other language representation models, BERT is a contextual model, and it is designed to pre-train deep bidirectional representations from unlabeled text by jointly conditioning on both left and right context in all the layers. That is why it is bidirectional. So BERT generally makes use of transformers, say attention mechanism that learns contextual relationships between words in a text. So in its vanilla form, transformer includes two separate mechanisms: an encoder that reads the text input and decoder that produces a prediction for the tasks. So since BERT's goal is to generate language model, only the encoder mechanism is necessary. So we do not need the decoder right now. So now you can see BERT base, we have say two architectures available for BERT here. One is BERT base and then BERT large. So BERT base has around 110 million parameters, whereas BERT large has 340 million parameters. So it is of course, deep neural network architecture, which is built on the latest advances in deep learning for NLP. We also have various forms for BERT available, distill BERT if I want to use on a smaller data and the lighter version. So various forms are available for us to use for BERT. Now, what exactly the terminologies in the BERT means are bidirectional. Of course, we understood that to understand the text you are looking, we'll have to look back. That means we are looking from forward to backward and from backward to forward. Then the transformers read entire sequence of tokens at once. In a sense, the model is non-directional, while because this is a difference between LSTM and BERT, that while LSTM reads sequentially, either from left to right or right to left, the attention mechanisms allow us to learn contextual relations between words because it takes whole chunk of words as it is. Pre-trained contextual word embeddings, that means it introduced a way to encode words based on their meanings and context. For example, nails can have multiple meanings, fingernails and the metal nails. And in the pre-trained models, it is easier for BERT to have a separate meaning for these two because it depends on the context where it has been used. Okay, so let's moving forward. By moving forward, let's see how we can use BERT in Python. And we need to use a transformer library before using any model in the for any BERT model in Python. And voila, we can use its magic. For example, here I am just taking a model name here. I am using a distill BERT, fine tune, and I am just taking for the English one. Then I am taking auto model for sequence classification, and from I am inheriting the pre-trained model with this name. Okay, then I am just using the classifier, and in the pipeline, I am asking it to perform the sentiment analysis because this is not the only task it can perform. These models can perform other natural language processing tasks also. So I'm specifying the task which I want this model to do is sentiment analysis, then the model name and the tokenizer. And then we can see I am invoking that classifier and passing this sentence: you are a very bad person. And even I have sent the English sentences as well. To pagal hai, I love you, you were the best. Now let's see the results. I am passing all four sentences to the classifier, and then let's see. The first label is negative, that you are a very bad person, and score is 0.99. That means it is this accurate, right? Then tu pagal hai, it has labeled it as positive sentence. That means it has not taken it properly. Then I love you and you are the best. These two are given very high scores. That means it is favoring that it is positive for a very high probability, right? So now you can just see with these 4 or 5 lines of code, I can just perform the sentiment analysis. Now, these English lines I've just used deliberately to see whether they work with English also or not. So if you can see, they were working. And how were they working? Because they have picked up the English words from it. right? And in this, Pupagala, they have not taken it properly. That is why it has given the score is like 932, because I have used the English model, the model which is trained on the English data set, right? Okay. So these are the some course recommendations. You can just go through these courses. These are the great courses available from Great Learning Coursera. And these are the course links available on the naukrilearning.com itself. So if you want to go deep into the sentiment classification tasks, you can just go through these courses. And finally, thank you. If you like this video, please like, share, and subscribe Naukri Learning. And thank you.